What? Yep. Eddie's first adventure, the Sonora Caverns. We gotta read the rule books though.
Actually, like some lower fault that runs off of this cave, this long line up here. Now, fault is a slip in the earth of about a foot. Out here in Sonora, we are still part of the Edwards Plateau, so we think that this fault may tie in with the Balcones network around San Antonio. Now, if you look in this room, you're going to see all of these circles in the ceiling, and then in each side of this line, the room looks exactly the same almost. Now, what we think happened here was rainwater collected in all of these faults and fractures throughout the cave. Then sulfuric gas from petroleum deposits deep underground mixed with this rainwater to make sulfuric acid. And that acidic water set in all these faults and fractures and ate away all this limestone from the fault out, making this symmetry. Now, all the water that was in here was part of the Devil's River water table. The Devil's River is about 80 miles east of here. Over thousands of years, the Devil's River eroded a canyon, which we can see today at Devil's River State Park. So as that water level dropped, so did the water level in the caverns. And after all this water left, that's when all the formations we're going to see started to grow.
It was just misty right now.
I can show y'all where this comes out. It'll be the very, very last thing that we see. And it'll just kind of show you how this cave is all interconnected. We have a lot of them here. Some of them are very famous, like our butterfly formation. Now, helictite forms by capillary action. They have small capillaries in them about the size of a hair. And gravity exerts enough pressure on all this limestone to force water through all these capillaries. They'll deposit their calcite, and that's why they grow in all sorts of weird shapes and directions. Some of them in the shape of a quarterback, like you see up here. When the first tourists started to come through in the 1960s, people started throwing money in these natural pools, using them as wishing wells. So that's stained with copper. That's one of the first signs of human-induced pollution that we're going to see in here. That's one of the reasons we don't let y'all bring bags. Aside from being cumbersome and you run the risk of running into something with it, you've got stuff in there that if it falls out, it's going to pollute this coral, it's going to create a toxic environment in this cave. Your camera batteries, makeup kits, spare change, stuff like that. And I don't have to worry about people putting formations in there either. And we're not really sure why that is, but we think it has something to do with the carbon dioxide level already in the cave, whether it be really high or really low. This water that comes through here can only hold so much calcite and so much carbon dioxide. It holds equal amounts. If it loses one, it's got to lose the other to stay in equilibrium. That's how reactions work. Now these stalagmites up here, these are called the candles. If you walk by this one, you'll be able to see that there's water dripping on it. The water dripping on the top, that's what makes it grow taller. The water that runs over the sides, that deposits calcite, makes it grow wider. Now a few things that kind of control the amount of water coming into a cave. Just a few variables. The first most obvious one, how much water is available to come in here? How often does it rain? Is this cave under a body of water? Things like that. About 2 months ago, we had some heavy rains come through the area. One of those all-day, 4 inches of rain kind of deal. So you can imagine the days after that, a lot of groundwater started to seep into this cave. In some of the spots where I was standing, it was like a rush shower at home. Lots of water falling down in there. Another thing is vegetation cover. Do y'all know what ash juniper is? Or what the locals call cedar? It's that evergreen looking tree that y'all saw coming in here. Water, small swimming pool's worth. This is all Dog's Tooth Spar. And up here, you can see the original water line. So when they broke in here, all that water came rushing out, and then it drained away, and it rejoined the water table below us. About 12 or 13 feet tall. Very cool to stand next to. This is not made of calcite. This is not a formation. This is nothing like we've seen yet. This is a paste, and as it's dripping, it's starting to coat this formation down here. This is called moon milk, and this is waste from cave microbes that eat this limestone. It's what they live on. This cave is warm enough to support life on its own. This stuff is made of calcium, carbon dioxide, and magnesium. People in medieval Europe found a lot of medicinal uses for this stuff. They can mix it with their drinks, and they can use it the same way that we use Pepto-Bismol or Alka-Seltzer as an antacid. Or you could spread it over a burn or a cut, and it would solidify in the open air, and it would form an airtight bandage. In this one, the layers are very, very evident. Now this bottom layer that kind of looks like carpet fringe, this is a layer, but that's where condensation corrosion is at work against. You see it? Okay. This is what's left of the butterfly formation anyway. In November of 2006, we had tour.
How was your first cave experience? Cool. Thumbs up? Yep.